Good afternoon. So today we're going to speak about Red Hat's software storage portfolio, and we'll also touch on the hyper-converged offerings and how they fit into Red Hat's portfolio. So when we look at organizations today, they're all going through evolutions, and the technologies in terms of how we develop applications are moving away from what we used to call waterfall, which is if you think about SAP or Oracle-based applications, you would spend months and months in terms of how you would plan and you would deploy these projects, to DevOps methodologies, which if you think about somebody like eBay, just simply moving the buy icon in terms of a product or a service where you would click to buy can result in dramatic change in revenue. And those sorts of things with a web page can be done on the fly. So we're now moving to these methodologies whereby our applications can constantly be changing, and they might change based on a region. So for, say, Korea, they might move the buy icon more to the right-hand side, and for, say, in Europe, they might move it more to the left, because culturally, in Asia, the right is considered a good thing, whereas the left is a bad, but in Europe, it doesn't really matter if it's left or right. Likewise, when it comes to how we actually build the applications, we're now moving to scenarios whereby we've split up the application. So if you think of something like Microsoft Exchange for email, if there was a problem with the application, the whole application would no longer be working. Then if we look at something like Google Gmail, if maybe, say, your contacts directory isn't working, the email service itself can still work. If there's a high demand for usage, then you can simply add additional containers, so you're creating a scalable application. And it's very different in terms of how we develop our software for these kinds of environments. And that also means for the storage stack, we have to look at things differently. So when it comes to the storage stack, if all of this is now becoming software, then everything needs to be software, including the storage. So for example, today, we can deploy storage inside of a container. We're one of the only companies that can claim to actually deploy our storage system cluster inside of container-based workloads. So we'll talk to more detail about the evolution of IT. When it comes to evolution of IT, if we look at this side of the screen, essentially we started from virtualization. So when we're talking about virtualization, we have solutions like KVM. So KVM you can think of like VMware's ESXi. It's the free edition that comes with Red Hat RHEL-based enterprise Linux. And then typically people would think, well, OpenStack, that's a competitor to KVM or to VMware, right? But actually, OpenStack is in the IT as a service part of what you can do. The actual real competitor to VMware from Red Hat's perspective is RHV. So RHV is our offering very similar to the VMware vSphere, and it gives you all those enterprise features that you would expect in terms of high availability, disaster recovery, vMotion. And we've just announced RHV-S, which is our hyper-converged offering. So it's essentially taking the Red Hat virtualization and then embedding that with our Gluster storage as a solution similar to Nutanix that you can buy as a single appliance. When we look at IT as a service, we need to understand that OpenStack is not directly a competitor to something like KVM or to something like VMware. In fact, OpenStack is for companies that need to do IT as a service. So what is IT as a service? Essentially, it's the ability to make things more automated and orchestrated in terms of maybe you want to deploy a new application or deploy a new virtual machine. You want to go through a self-service portal. You can use something like CloudForms. And CloudForms will give you that capability. Like if you wanted to go onto Amazon.com and you wanted to then provision a new virtual machine, and you can have that all self-service for developers, then in that case, CloudForms and OpenStack can combine together to give you those capabilities. OpenStack typically working in the scale of hundreds to hundreds of thousands of virtual machines, whereas RHV or your VMware equivalents are working in just hundreds of virtual machines. And finally, on the Ansible side, we will use Ansible to automate that environment, and Ansible is actually used in our storage systems themselves as well. When we talk to DevOps, so essentially from a storage perspective, you want to now move into environments where you can use services like OpenShift. OpenShift, I would think of OpenShift like a library, right? You can go to a library, you want to pick up a topic on a specific book, and you can read in detail about that book. When it comes to developing a new application, maybe you want to put something like a high availability database in there, but you don't have the knowledge or the structure of how to create that database. OpenShift can simply via API make a call or command to go and create that database for you. So it makes it very easy for a developer to go and develop new applications. because they simply have all that library available. They can call upon a high availability database. They can call upon additional storage, and all this can be automated. So it's very easy to deploy and develop new applications. And then that leads us to containers, whereby our storage systems support developing these new sorts of applications within container environments. And all of this can be done as a hybrid cloud. So essentially, you can run it in AWS, or you can run it within your own data center. So these solutions are available. And regardless, the storage stack sits across all these tenets. So virtualization, IT as a service, or DevOps, you can actually use these technologies across all of them. So we come to the next topic, which is bimodal IT. When we're talking about bimodal IT, it's a concept from Gartner. And essentially, bimodal IT is talking about the ability to work on traditional workloads, so things like your SAP, your Exchange, or Oracle, and work on Mode 2 workloads, which are things like your web applications, your Amazon, your Googles, anything that's based on a web-based application. But what it's defined by, if you can see at the top of the screen there, is the word uncertainty. So when it comes to Mode 2, there's nothing that's constant. It's constant in terms of change. Things are constantly changing, but it's not very traditional in terms of things that don't change much. So SAP, Oracle, you kind of know what the application is, you can size it, you can deploy it, and things progress off a very slow basis. Whereas in Mode 2 workloads, you've got this constant change, constant uncertainty. You might make constant different iterations to the application. So in these different scenarios, we have Mode 1 on the left-hand side here. So Mode 1 is your traditional environments. So typically, they're made up from your hypervisor with some servers. So in this case, you could use something like Red Hat virtualization. And then you've got your operating system and application. Typically, we will provide NFS-based storage to these guys, and then you can provide CEPH file services out the back there. So that's how our Gluster storage offering typically works in Mode 1. And then in Mode 2, you can have scenarios like this. So the operating system is actually replacing the need for a hypervisor. And in those cases, typically, again, we're providing NFS storage into application containers. And finally, in OpenStack, leveraging KVM for your virtualization layer, or potentially you may even use VMware for your virtualization layer in OpenStack. You have your OS and application. And then we have, again, the ability to use not only NFS, but to use Object, RDB, and NFS. So we have all these different protocols available. So when it comes to Mode 2, essentially we have a Swiss Army knife. We have multiple different protocols available. In Mode 1, we have the ability to actually leverage object-based storage as well. So our Gluster storage system can provide Swift-based object access. In doing so, it allows our Mode 1 technology to speak to our Mode 2 technology. Likewise, with our Mode 2 technology, we have capability with iSCSI, file, and NFS, which then allows you to provide storage services from your Mode 2 web-based applications back into your more traditional virtual type environments. And then the final piece here is we're converging this layer. So we talk about hyperconvergence. Essentially, we're taking the storage system, the server, and the hypervisor, providing it in one layer. So you can get your Red Hat Enterprise Linux with your RHV-based virtualization engine, or KVM, and then the storage system being Gluster. So these are the two different technologies in terms of Mode 1 and Mode 2 and where they sit in our storage portfolio. To give you more detail on the workloads, the kinds of applications that will be used in these environments. So traditional being Mode 1 and next generation being Mode 2. In those environments, we can see here that the media and entertainment, medical, video surveillance, broadcast media, typical virtualization and file, all these sorts of things are what we will classify a traditional type application. The workloads are quite constant. We know how they work, and they're very basic in terms of the storage connection. When we get into next generation workloads, you can see they're more modern technologies. So things like containers, Hadoop, web applications, analytics, even NoSQL. So you can see NoSQL there. NoSQL is a modern database. Things like MongoDB or Postgres, they would be considered modern databases. We don't traditionally do things like your Oracle databases or your RDBMS-based database. And all of these things are very different in terms of the way we need to structure them. So you can see there object-based storage, content delivery, sync and share. So these are the different workloads that typically would be make up on a next-generation system. And you can see that the coloring scheme here, so anything that's dark orange is our CEPH storage product, and anything that's the lighter orange is Gluster. And there's a little bit of a gradient between those where they can transition over. So we talked about using Mode 2 technology to talk to Mode 1. So then, if we go to the left-hand side, you can see that they have physical infrastructure. So In physical, you can use Ceph and cluster storage with Red Hat Enterprise Linux. In the virtual side, you can use cluster storage software with Red Hat Enterprise Virtualization. And then in the cloud scenarios, you've got things like OpenStack. So for OpenStack, you can use Ceph storage. In fact, about 60% of all OpenStack deployments are using the Red Hat Ceph storage. When we're talking containers, we can use both Ceph or Gluster. The concept here is really about scale. So if it's a larger scale, typically it may be Ceph. If it's a small scale, typically it may be Gluster. And of course, those can be powered by our container-based systems using DevOps methodologies with OpenShift. And then finally, when it comes to public cloud, the Red Hat Gluster storage software can sit across Amazon, Google, and your typical Rackspace type deployments with OpenStack. So that's sort of just an idea of where the different technologies fit in our portfolio. So now we're going to take a little bit more in-depth look at what is Red Hat virtualization. So Red Hat virtualization is made up essentially of Red Hat Enterprise Linux with KVM. So KVM is the foundation. It's free. It comes with any Red Hat Enterprise Linux subscription, but it's not very scalable. In fact, it can only go to a maximum number of 4 virtual machines per host. It doesn't have centralized management, and it doesn't have enterprise features. So if you think about, say, VMware, you've got things like vMotion to move virtual machines from one machine to another. It doesn't have those capabilities. Just very basic virtualization. You can think of this one like VMware ESXi. So it's very limited in terms of what you can do, just very basic virtualization. However, here we have Red Hat virtualization, which is just like your VMware vSphere. So it's going to give you the capabilities for enterprise features like vMotion, DR, high availability, all those concepts that you'd be familiar with from, say, VMware, centralized management, all of that is within Red Hat virtualization. So there's the difference between your typical basic virtualization with KVM and Red Hat virtualization. It's also very scalable, unlimited number of virtual machines, and in fact, it's been proven to outscale in terms of density, so you can get more virtual machines into a Red Hat virtualization system than into a equivalent VMware virtualization system. We've gone through a huge amount of iterations. So Red Hat virtualization originally comes from KVM, which was acquired via Mawer, which was in 2009. And in our latest release, which is 2016, version 4 of the product is our 10th release. And a huge number of features and reiterations across the way, additional enterprise features, and things like that being added. So what stands out with Red Hat virtualization is that regardless of industry, it is applicable across all customers, be that an education customer, be that a media and entertainment company, or a technology company. Anybody can leverage Red Hat virtualization, no different to how anybody could leverage virtualization from, say, Hyper-V or from VMware. Typically, one of its standout features is the fact that it's about 50% the cost of the VMware equivalent. So similar management, similar feature sets, but 50% of the overall cost. So finally, when it comes to virtualizing all these environments and trying to make it simple, we introduced the Red Hat Hyper-Converged offering, so RHVS, and it's combining Red Hat virtualization with Red Hat cluster storage. We're also using the Ansible gdeploy tool, so essentially we have automated the deployment of these technologies. So for example, you get a cluster of 3 servers, and then you use Ansible to automatically deploy that technology and configure it. You can bring your own hardware, or you can use existing hardware, so you don't need to buy a physical appliance. You can actually just leverage existing hardware based off a reference architecture. Typically, we work on 3 nodes, and we can also leverage Red Hat directory services and native file server capabilities. Finally, if you want to bring all that data back, so you've got, say, remote sites, you can bring all that data back to one central location. You can have one large cluster storage pool, and then in that pool, you can actually have multiple different locations replicating their data, so it removes the need for backup software and backup tapes and those sorts of things in your remote sites. You can replicate that data back to a central location. So very quickly, in terms of the specification, we have smaller specifications today because this is our limited availability release. So from 64 GB of memory up to 256 GB of memory. And in the capacity, we've got 12 TB up to 80 terabytes. So they are fairly small systems today. They are our limited availability release. But as we move forward and progress the technology toward general availability, then you'll find that these systems will become much more scalable to the likes of, say, Nutanix that you're putting in a data center. Today, maybe they're more remote offices and branch offices whereby you might be using those out in the field. So now we'll talk a little bit about OpenStack. OpenStack is really defined by scale. So when we're talking about scale, we're talking about the ability to run thousands to tens of thousands to hundreds of thousands of virtual machines. And when it comes to running these machines, the benefit of OpenStack is not really virtualization. A lot of people, typically they looked at OpenStack thinking, okay, it's an alternative to VMware. In fact, KVM or RHV is the alternative to VMware. OpenStack is if you wanted to be a IT service provider, like you wanted to be a Amazon Web Services, or if you wanted to be a large telco provider, providing massive scale of different systems, different virtual machines, for instance. Again, hundreds or thousands of virtual machines, then this is the sort of scale where you probably look at OpenStack. So maybe a large financial institution, a large research university, typically OpenStack used in those kind of environments. Essentially, it's delivering automation, provisioning, orchestration, which means it's simplifying the environment, how you can run those systems, and the complexity of that environment. If we then look at the storage layer, CEPH within OpenStack. So CEPH within OpenStack is defined by different protocols. LibRados, using a Rados gateway, is providing object-based storage. We then have Cinder and Glance, which is provided by RDB, which is block-based storage, so similar to what you would get via, say, your iSCSI protocols and those sorts of things. We're using RDB. And then Manila is the new libceph concept, so essentially providing file systems. So you can actually have a completely unified system for storage within Ceph. And you can see these OSDs. These are how we split the data out, so we split them out onto multiple different nodes, so it's a scale-out based storage system. So when it comes to OpenStack, we've now announced a hyperconverged offering for OpenStack as well. So essentially, when you buy the hyperconverged offering with OpenStack, you get 64 terabytes of Ceph included for free, so you can start developing on top of that OpenStack platform immediately. You don't even need to buy an additional Ceph license. It's got everything built in, so you can deploy it similar to how you would say a Nutanix solution. Great for telco providers and things like that that may be looking at various options to deploy OpenStack and don't already have existing OpenStack deployments. It just simplifies the whole thing by including the storage stack as well as the compute stack and the various nodes required to build your OpenStack systems out. And it's got built-in backup capabilities as well in terms of active-active replication and as well as snapshots. So the kinds of customers that may use this, again, are defined by scale. So large telecommunication companies, large universities, looking at, say, large research projects and things like that, they're typically the customers that would deploy Ceph and OpenStack. A few examples we'll talk to here are customers like Yahoo. So Yahoo actually sits across two different segments. They need both balance and throughput, as well as large capacity. Yahoo actually use Ceph storage for the Flickr photo sharing service. And when they use that, they use the community edition. They don't use the Red Hat version. In fact, they are a large contributor to Red Hat community in terms of services like replication and the way we shard data, so the way we protect data. A lot of that technology has actually been developed jointly with Yahoo through their contribution to our open source community. Likewise, we have other examples. So, for example, Facebook and Bloomberg are using this in the media industry for streaming media and those sorts of things. And then when we look at the high-performance database side of things, we can think things like MySQL, MariaDB, and Postgres, as well as Medallia is the customer in this case using that. So different examples, different databases for high-performance requirements. And you can see here that this, again, goes back to the concept of being a Swiss Army knife. Ceph storage can actually be applied for high performance, can be applied for a balanced environment, or just a deep, low-performance capacity archive environment. So when we look at containers, containers are essentially that ability to break out your application and scale your application. You might start with one container and move to, say, 100 containers. The thing that you need to know about there is that we need to keep the storage always available. So we can keep the storage separate from the overall RHEL operating system that you might be using to run your containers. Or we can actually converge it into the same layer, so we can bring up the storage stack and we can do a hyper-converged system with both RHEL running the Gluster storage system and running your application containers on top of that. So we're giving you flexibility in terms of deployment options, be it hyper-converged or separated systems. So an example of how we use containers and storage is if you can imagine you have an application using a MySQL database. That application might start out as one container, and it may scale to 100 containers. But when you need to take away some of those containers because your peak workload's gone away and you maybe go from 100 containers down to 10, what happens is the container goes away. But you still need to keep the data. Now, within a container, there's no ability to write natively into the container data. And if there was, you would lose that data anyway. So you need to keep your storage separate from the container. And when that container comes back up online, the same database needs to access the storage. So this is the concept of persistent storage for containers. So with our Gluster and CEPH offerings, we have capability with OpenShift today to integrate and provide the ability to actually run those container systems. You may start out with 10 containers running MySQL. You maybe then take some offline, you go down to one container. You then need to pre-provision that and connect back to the storage. So the point here is MySQL as a database needs its data available all the time. If you're running 10 containers or 100 containers, the storage remains consistent whilst the containers come and go. So we talked about mode 2 and mode 2 being uncertain. Well, this is a very good example. As the application goes away, that's your uncertainty. You still need to have certainty with your storage. And that's where Gluster can address those concerns with persistent storage. Typical use case for customers, file serving archive. So we use Red Hat Gluster storage here. It's tested to a very large scale, so 38.4 petabytes of usable capacity. So very, very large scale. Typical use case is a consolidation of file servers. So if you're an insurance company, you have maybe multiple Windows file servers. You want to bring those down to one single system, as, say, Prudential Insurance did in Singapore. Then they use Gluster to do that, to long-term retention of those contractual data. Typical enterprise features, automated tiering, and things like snapshotting, replication that you would expect from an enterprise system. We also have backup offerings whereby Gluster can be used as the back-end storage down the bottom there. So Gluster has a very cheap economic value that you'll see later. It's very affordable. So it can provide very good, cheap, long-term storage retention in your backup offerings and leveraging the built-in deduplication of a typical Commvault system. We also have sync and share solutions, again, providing the economic, cheap storage underneath for long-term archive and long-term storage of file sync and share solutions. Again, this is an example using Commvault. There's some other technologies out there from other organizations that can also use the back-end Gluster storage. So Gluster is defined by scale, and when we talk scale, anywhere from 160 terabytes, 512 terabytes, up to 1 petabyte, we have fixed systems that are available as configurations with the hardware and the software that you can deploy today. So we've made it very easy to go out and deploy these systems. If we look at the economics of this, this is where it becomes really interesting. You start to see the value of Red Hat's portfolio in storage. So the bottom two lines are the cost per usable gig per month. So if you think about Amazon S3 or something like that, or Amazon EBS, you have an example there of how much it would cost per month to run the Gluster storage system. The next two lines are the premium and standard offerings for support with QCT hardware. So it's both the software and the hardware cost per month, per gig, usable storage. And you can see there, the bottom line there where it ends up, that's the orange line of Amazon. That's Glacier service. So it's the cheapest service available from Amazon today. If we look at the top there, that is the Amazon hard disk provisioned for higher performance, high throughput workloads. That is the cold performance tier. And then that one there is the S3 performance tier, so higher performance from S3 object. And then that is the lower cold performance tier from S3. So you can see an example of just how much cheaper we are than Amazon. But then we also have EMC Isilon and EMC VNX built in similar configurations. So in some cases, up to 4 times cheaper than traditional storage systems. So the hardware behind these, in this case, is QCT hardware. QCT in Korea is available from eSlim. They have a partnership with eSlim. In terms of the performance capacity, you've got a balance here with SSD in that node and up to 12 SSDs in the 1 RU chassis. Then you have a 4 RU chassis, and the 4RU chassis is combining up to 70 drives, so very high capacity in a small footprint. And that's essentially a half a petabyte of raw capacity within 4 rack units. So very, very dense configurations. If we look at the various configurations available, the thing that stands out again is the capacity that's available in these configurations. So very dense configurations, either in the higher performance segment for smaller files or in the large capacity archive, all that balance of throughput for higher performing, high capacity workloads. So to give you some examples where, say, we're seeing a lot of trend for very large-scale storage, and one of those is CCTV, so security systems or smart cities and safe cities. In China, China actually represents 40% of the overall global spend in terms of CCTV. And you can see exactly why that is. This is an example of the China government testing cameras for some of their safe city projects. Examples of how it might be used is real-time analytics, so actually analyzing all that capacity of data that's been stored, and real-time you can see that the traffic is going in the wrong direction here. So what can be done about that? Essentially, we can use number plate recognition, analyze the number plate, and we can issue a fine to that vehicle without ever having to send a police officer to intercept the vehicle. Likewise, if you're familiar with Facebook and facial recognition today, you can use facial recognition to actually tag persons of interest. And in Boston, for instance, the Boston bombing, they used this similar technology to actually identify anybody wearing a white t-shirt and a red cap, and they were able to track those people through different footage across the city to then identify and track the person down. This is an example of how the technology combines together with CCTV and long-term data storage for analytics of your CCTV data. So a typical solution may look something like this. In this case, you've got your IP cameras connected back into a video management system, so somebody like maybe Milestone Systems or Axis. And then we've got the long-term replication of data, so you're going down to a large pool of data, and you're having a secondary copy of that data for security purposes, for disaster recovery. Remote sites can come in. And then the next concept would be broadcast media. So if we look at the high definition content today, you can see that it's 4K digital TVs, so very large storage capacity required for all that data. But at the same time, we've actually now moved away from 4K to 8K, in which we've doubled the requirement for storage. So in doing so, we also need to get the content down onto our mobile devices, yes? So we've got massive, large, high definition videos. We need to bring those down to from a large format to a small format, and we have a broadcast solution that can do that. So in this case, we've got transcoding. We can do that with things like OpenShift and containers on the fly, resize the data down, and then get it down onto your mobile device or your IPTV. All the meanwhile, that data is stored on Gluster storage. If a TV series is very popular, it can be automatically tiered up onto, say, a flash storage medium. If it's not being accessed so frequently, it can be tiered down onto a lower storage, like spinning 8 terabyte drive. So you can get your capacity and your performance benefit there. And you can replicate your data out using technologies from Aspera and Signiant, who are typically used in the broadcast industry for replicating data. So in summary to where we are, we've come a long way with CEPH and with Gluster. Gluster, you can see here, is not necessarily getting the same amount of change, so the requests that we're going through in terms of how we actually modify our storage code, whereas CEPH is a Mode 2 system, so it's very much under high development. And the reason for that is that Gluster is sitting in that traditional, very certain, very mature market. So your typical file, large-scale systems, it's a mature market. There's not much of features and requests. You've already got your snapshot, your application, all those technologies. Whereas CEPH, looking at things like objects, recently we've introduced BlueStore, which is our high-performance blocker backend for CEPH. All those constant iterations and changes in the Mode 2 world, you can see those represented here in terms of our development and the amount of change that happens in our open source community. So final picture here, if you want to take a picture, this will give you a link to either QR code or short link, and that is where you can access a console for Red Hat storage with either CEPH or Gluster, and you can play with those two different storage technologies so you can get hands-on and have a feel for what the management consoles are like and what the technology is like to manage day-to-day. So I'll give you a minute there to take a picture. And if you have any questions, feel free to come and ask me after this session. And with that, I thank you for your time, and I hope you enjoyed and benefited from today's session. Thank you very much.